This is my fourth video lesson for Unit 10. In this lesson, we'll be analyzing the effect of entropy in nature. Go to page 18 in the class packet. Motivation: define disorder. Why do wires get tangled? We'll be answering this question in this lesson. Learning target: at the end of the lesson, I'll be able to explain what factors affect entropy. Homework be number 4, which be a Junipod based off this lesson. Entropy is defined as the measure of the number of possible arrangement or disorder in a system. The symbol of entropy is S. Enthalpy is the change of energy in the process, represented by the symbol H. Disorder can be defined as not organized, hard to predict, random, lots of ways for the particles to arrange themselves. Here's an example of a room with lots of disorder or chaos. Here's an example of a clean room where there's not a lot of disorder or chaos. In a clean and order room, there's only a certain amount of ways that you can arrange the stuff. But in a room where there's lots of disorder, the stuff can be arranged in many ways that would be considered chaotic. So entropy can also be defined as the measure of disorder. The more possible arrangement, the higher the disorder. The universal law is that all changes, physical or chemical, tends towards higher entropy and lower energy, which is enthalpy. You have to memorize this for the Regents exam. Take a moment to watch a TED video about entropy. The link to the video will be in the description. Once you watch the video, resume this one. Learning check number 1. Systems in nature tend to undergo changes towards what? Pause the video and resume once completed. The answer is choice 2, lower energy and more disorder. Learning check number 2. Which term is defined as the measure of randomness of a system? Pause the video and resume once completed. The answer is choice 2, entropy. Here's a diagram illustrating that things that are ordered have low entropy. Notice in this order system, there's only very few arrangements, compared to a disorder system where there's lots of possible arrangements. Therefore, when you mix two things, there's a higher chance it will be like this than like this, because this is more likely to happen. Here's another example in your packet. Imagine you're throwing bricks to the air. Which is more likely to happen? The scenario on the right is more likely to happen because a pile of bricks has more possible arrangement than a wall of bricks. The wall of bricks only has maybe 1 or 2 possible arrangement, but this pile of bricks has many. Therefore, this pile of bricks is more likely to happen. Let's look at one more example to help you understand entropy. Let's say we have a system with 2 possible states or arrangements, heads or tails. Let's look at the first scenario, in which we get all heads. In the second scenario, we get a different amount of heads and tails. Question 1. Which is more order or disorder? Scenario A will be more order because it only has one possible state, all heads. But scenario B will have more disorder because it has a mix of heads and tails. Question 2. Which is more likely to happen? Scenario B is more likely to happen because it has more possible states. So if you were to flip the coin 5,000 times using a computer simulation, you can see that you're more likely to get a mix of heads and tails. So the relationship between disorder and arrangement is that the more arrangement there is, the more disorder, the higher the entropy. Here's an equation in which you can calculate the entropy. Kb is the Boltzmann constant, and n is the number of possible states. Perpetual motion is a machine that does work continuously without external energy. Here are some examples of perpetual motion. The question is, do they exist? Take a moment to watch a TED video about perpetual motion. The link to the video will be in the descriptions. Once you watch the video, resume this one. There are 4 laws of thermodynamics. The 0th law states that if 2 systems are in thermal equilibrium with the third, then they all are thermal equilibrium with each other. We discussed thermal equilibrium in the energy unit. The first law of thermodynamics is the law of conservation of energy. Energy cannot be created or destroyed. The second law of thermodynamics states that the state of entropy of an entire universe as a closed system will always increase over time. So whenever you have a closed system, entropy will always increase. The third law states that the entropy of a perfect crystal is 0. when the temperature of a crystal is equal to the absolute zero, which is 0 Kelvin. So now we're going to discuss 5 things that can affect entropy. They are phase, temperature, volume, mixture, and reaction composition. As we go over each one, think about how it can affect the number of states, randomness, disorder, and arrangement. The first factor that we're going to cover is phase and how does it affect entropy. Here we're given 3 phases of matter, solid, liquid, and gas. Which one do you think will have the highest entropy? It will be the gas, because the gas is the most random and has the most disorder, then is liquid, then is solid. Different phases have different number of states. Solid has the least states, liquids has more states than the solid, and gas has the most states. Therefore, the gas has the most entropy. To go from a solid to a liquid to a gas, you must add energy or increase temperature. That's why gas has the highest average kinetic energy compared to liquid and solids. So the relationship between entropy and temperature is a direct one. Entropy increases when temperature increases. So gas has the most entropy, then aqueous, then liquids, then solids. So entropy and temperature have a direct relationship. Here's a graph of entropy versus temperature. The higher the temperature, the higher the thermal energy the system has. The higher the thermal energy the system has, the more ways there is to distribute the energy. That's why when temperature increases, entropy increases as well. Learning check number 3. The entropy of a sample of water increases as the sample changes from a what? Pause the video and resume once completed. The answer is choice 3, from a liquid to a gas. Learning check number 4. Which 1 mole sample has the least entropy? Pause the video and resume once completed. Entropy and temperature have a direct relationship. So the least entropy have the lowest temperature. So 3 and 4 are wrong. 1's a solid and 2's a liquid. Solid has less entropy than liquid. So the answer is choice 1. The next factor is volume. Let's say we have a container filled with gas particles and we increase the size of the container, but we still have the same number of gas particles. Did the entropy increase or decrease? The entropy increase. Why? The larger the volume, the more ways there is to distribute the molecules. The more ways to distribute the molecules, the higher the entropy. The next relationship that we're going to cover is entropy and mixture. In this diagram, we are dissolving salt in water. We are creating a mixture. So what might be the relationship between entropy and creating a mixture? By creating a mixture, we're increasing entropy. Why? Because mixtures have more possible states and arrangements, more randomness than unmixed systems. So when we mix things together, entropy will increase. The last factor that we're going to cover is entropy and reaction composition. Here we see a chemical reaction. Oxygen is reacting with hydrogen to form water molecules. These are the reactants and these are the products. Let's first count the molecules on the reactant side. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now let's count the molecules on the product side. 1, 2, 3, 4, 5, 6. Which one do you predict will have more arrangements? That'll be the reactant side, because more molecules means more possible arrangements. So when this reaction happens, entropy will decrease, because there are more arrangements in large amount of molecules than small amounts of molecules. Since during the reaction, you went from 9 molecules to 6 molecules, the number of arrangements decreases. Therefore, entropy decreases. So as the number of molecules increases, entropy increases. As the number of molecules decreases, entropy decreases. Learning check number 5. Which reaction shows an increase in entropy? Pause the video and resume as completed. The answer is choice 2, because you go from 2 molecules to 3 molecules. The number of arrangements and states increase. Therefore, entropy increase. This concludes the video lesson. Remember to do the JunoPod homework.